Okay, so Foundation Math 10, we are going to start 3.7 here now. 3.7 is multiplying polynomials. So we've talked about multiplying binomials. What happens if we don't have just two terms in those expressions? What happens if we have three terms or 4 or 5 terms that we're trying to multiply, like this example right here? So what I want you to do is I want you to draw a rectangle that has length of A plus B plus 2 and a width of C plus D plus 3. So I want you with a partner, see if you can figure this out, draw a rectangle with these dimensions and find out what the area of that rectangle is that will represent the product. Okay? So once again, you want the one side to be A length plus B length plus 2 length, and the other side to be C length plus D length plus 3 length. And I want you to find the area of that rectangle. With a partner, take a couple minutes to try and do that, and I'll show you, we'll talk about it in a minute, okay? So on a fresh piece of paper with your notes, go ahead and try that. All right, so what you want to do is you want to draw, like I said, a rectangle with basically like a width of this. So let's draw that. So I'm going to say, here's A right here, and here's B. These are just random lengths. This is 3, okay? That's, or 2 on this side. Yeah, sorry, 2. Okay, so that'll be 2. You guys see, is that showing up? Okay. Now, on the length side, C plus D plus 3. So let's go C, okay, plus D, and plus 3. Now, does it matter what lengths they're? No, it doesn't. What we're trying to do is trying to find what the area of the rectangle would be. And the best way to do that is to make these in sections. Okay, so we're going to make these in sections. I'm going to draw lines like this. Did anybody start by doing this kind of thing? Yes. Anybody do this? Okay, so that's the rectangle. To find the area of the rectangle, we want to add up all of the areas of the parts of the rectangle. So this area is the length times the width, because it's just it's a rectangle, right? So this is going to be AC. This section is it's another rectangle. It's a width of A, a length of D. So this is going to be AD. And this part right here is going to be A times 3. Now we usually write the number first, so I'm going to write that as 3A. Okay? This one is BC. This section right here is B times D, and this is going to be B times 3, or 3B. Finally, C times 2 is 2C, 2 times D is 2D, and 2 times 3 is 6. So the area of the rectangle is going to be AC plus AD plus 3A plus BC plus BD plus 3B plus 2C plus 2D plus 6. Now, are there any like terms in there that I can combine? Any like term? Can I simplify this at all? Remember, like terms have to have the exact same variables multiplied, whatever, like AC, and they have to have the exact same exponents on each of those variables. The numbers in front can be different. It's the variables and exponents. So, whoops, what happened there? I don't know. Okay. All right, so now what I want you to draw your attention to is we're not going to have to draw a rectangle every time we're going to multiply this, but what I want you to see is this, is that this first part is AC. Here's A, and here is C. They're connected there. They're both the first terms in each one. The next section as we move along is AD. Well, that's A times D. The third section, 3A, would be A times 3. So what I want you to notice is that we are taking this first term in the first polynomial there, in the first expression, and we are distributing, we're multiplying by each term in the second polynomial. That's how we get this first row. The second row, I'll change colors, BC, look at this. We move to the next one, and we go B times C. Then we go B times D, and then B times 3. That's how we get the next row. And finally, what color should I use? Black. 2 times C times D and times 3. That's how we get the last row. So really what this translates into is we are going to be distributing just like we do with binomials, okay? But binomials has a little word to it, the FOIL method, remember that? So some of you, you like that FOIL method, but really it's just a memory thing to help you remember how to distribute, all right? So recall, as an example, okay, remember this, A plus B times C plus D. If we were to do that, the FOIL method says we take the first terms and multiply them. Hey, that's what we did up here, AC. And then we do the outside terms. Well, we just continue to take this first term and distribute it to all the other terms. So that's plus AD. Then we go to the next term and inside, so FOIL method, BC and BD. So really the FOIL method is distributing each term from the first expression to multiply by all the terms in the other expression, systematically, one at a time. And so that's what we do. We just distribute. So when we expand, okay, that means multiply, because we have multiply as an operation in between here. And we are going to distribute. So the big word is distribute. And when you distribute something, that means you give out something, right? You distribute whatever it is, gifts to the poor, or you distribute candy or whatever. So you are the source, and you're going to make sure that you distribute to everybody else that you are affected by. So this 2h, even though this is a binomial, and this is a trinomial, this 2h is going to distribute its multiplication to each term in the second one, like that, okay? And I usually draw arrows like that. So 2h times h squared. Here's where you got to remember your multiplication rules. That's 2 what? H cubed, right. You add the exponents of the variables that are the same. When you multiply, you add their exponents. That's 2h cubed. Good. Then we have 2h times a positive 3h. You got to remember the signs here. So 2 times positive 3 is plus 6. And this is going to be h squared, because this is an h times an h. And finally, I don't move to the 5 yet. I got to finish 2h times negative 4, which is minus 8h. So the first level of distribution is done by the first term multiplying to every term in the second expression. Got it? I'll change colors here. Let's go to the next one. You have to consider this a positive 5. That's important. So positive 5 times h squared is plus 5h squared. Positive 5 times a positive 3h is plus 15h. And then 5 times negative 4 is going to be minus 20. Awesome. Now, we are not done because we have some like terms to combine. So I see that I have 6h squareds here, and I have 5 more h squareds. So you should write that as a combined. Now we don't have any h cubed, so I'm going to write the 2h cubed there, just as by itself, because it has nothing to combine with, so we'll retain that. And then we have plus 11h squared. Good. Any other common terms that you see?
8h and 15h.
8h and 15h, very good. So negative 8 plus 15 is going to be?
Plus 7.
Plus 7h, very good. Negative 8 plus 15, or 15 minus 8, think about it that way. And then there's nothing to match with negative 20, so we'll just write minus 20 there. So a couple things. We don't have any more like terms to gather. We've done all the gathering correctly. And notice that I've written this in descending order or of the variable, which means that the largest exponent term is written first, then the next largest, then the next largest. And this technically is h to the power of 0, because there's no h, so that is the last one. Constant is always at the end. So this is a good habit to get into, okay? I would like you to get into that practice. Expand, gather like terms, simplify by gathering like terms, and we'll write it in the proper order. Okay, any questions about that? All right, let's do another one. Let's do these ones. So go ahead and jot those down in your book as 2 more examples. The first one looks a little different, but you're going to see this lots in math. And so we just gotta, I wanna make sure that you understand what this actually means.
You just do r squared plus 5t squared.
Okay, good question. Well, I'll address that in a second. All right, let's take a look at A. Now, students get this wrong all the time, and I try and make a big deal of it in grade 10 here, so that when you're in grade 12 in calculus that you don't make a mistake on this. But this is why I make a big deal of this, because it appears that you might want to distribute this 2, the squared, into here. But please do not do this. No. Okay? It's this, the incorrect answer is 2r all squared plus 5t all squared. That is the incorrect answer. So this is not 4r squared plus 25t squared. That is not the correct answer. So we can distribute multiplication, but we cannot distribute the exponent across a multiplication or an addition like this. Okay, so this is not allowed. So please don't get into that. And that's just a trap that if you're not thinking, you fall into. What this actually means, this squared, it means that this expression is multiplied by itself. That's what squared really means. It's something times itself. So really, you ought to think about this like this: 2r plus 5t times 2r plus 5t. That's what that actually means. So please make sure that you don't get caught there. And so now we distribute. Again, if you want to think of the FOIL method, fine. I would encourage you not to think of the FOIL method anymore, but to think of distribution, because that's applicable to all sorts of expressions with number of terms. So 2r times 2r is 4r squared. So 4r squared is part of the answer, but not the complete answer. I have now plus 10 RT. So 2 times 5 is 10. R times T is written as RT. Okay, so this first term has multiplied by everything in the second expression. Excellent. Now I move on. So 5T times 2R is plus 10 RT. And I have 5T times 5T is plus 25T squared. So this is 4R squared plus 20 RT plus 25T squared. So again, these are like terms because they have the exact same variable and exponent combinations, so I just add the two numbers in front to get 20 RTs. Yes, question?
So that one, wouldn't you put 25t squared at the front?
Okay, so would you put 25t squared at the front? Well, we have two squared terms, right? When you have more than one variable, the order of writing things is not as important, honestly. It's if you have one variable, usually the descending order of the one variable. But if there's more than one variable, because if you put the t squared term in front, well, why would the r squared term go back there, right? I mean, it's alphabetical, really, so this would be a better argument to have r first and then t, but it doesn't matter. Doesn't matter. Good question, though.
So it just doesn't matter.
No, it doesn't matter. When you have more than one variable in expression, don't worry about the order right now. Okay, good. Any other questions about that? All right, let's take a look at the second one then. And I'm actually going to just bring that down here. I have a little more room to work. Okay, so let's distribute this. We do have 3 terms in the second one, so no problem. I'm going to start with 3x, and I'm going to start my multiplication there. So I got to do that 3 times. So this is going to be 12x squared minus 9xy plus 15x. Okay, now does that look right? Everyone okay with that? Okay, moving on to the next one here. Let's distribute this. So I'm going to have minus 8. And I always put the letters in alphabetical order. because when you multiply x times y, that's the same as y times x. Okay, multiplication can go both ways like that. But if you write xy one time and then yx another time, you might miss that those are like terms, right? It might fool you. So what I'm saying is that if I wrote this as 8yx, later you might say, oh, these are different. You might think they're different, but they're actually like terms. So that's why I always, when I'm writing multiplication, always write in alphabetical order, okay? So sorry, where am I at again here? No, so this is x, y. Even though the y looks to be first, you see? Write it in, because now we see obviously these are like terms. Okay, next one, plus, we have a negative times a negative here, plus 6, and that's y squared. Okay. And so finally, I'm going to do minus 2 times 5 is 10, y. Okay, are we good with that? Everybody good with that? Yes? Looks good? Okay, so now we look carefully at any like terms. Do we have any like terms? Well, we did notice these ones. So let's gather those. I don't think we have any other like terms, do we? So again, the order doesn't really matter too much if you have more than one variable. I'll write this 12x squared first. I will now combine these. And when you're doing this work, it might be a good idea just to stroke them out so you know that you've combined them. Because there might be a whole bunch of like terms and you have to kind of systematically stroke them out or whatever. So what's negative 9 minus 8 is negative 17xy. So that combines to negative 17xy. Don't forget about your 15x and your 6y squared and your minus 10y. So I'm not too concerned about the order with more than one variable. Okay, does that look about right? You do have this, which one is it? Yeah, you do have this in your textbook, so how do we do there? Yeah, looks exactly like what they have. So that is good to go. All right, any questions about that? All right, I'm going to do another example that's a little bit, maybe a little bit more confusing, but I want you to write this one down. Okay, next example, boys. Here we go. Yeah, write this one down, please. All right, so now we get into multiplying lots of things, and now we're adding some things too. Like this one is a little, we have to take this one apart carefully. So what we see is that we have one grouping that's multiplied here. So that's multiplication here. It's separated by a plus, so we are now adding another group of multiplications. So we have two groups of multiplications that we have to add. So order of operations say we do our multiplications first. If you remember BEDMAS. So brackets, exponents, division and multiplication come first and then addition. So we're going to do the multiplication. We're going to expand first. So how do we expand? Well, this one's easy. This is going to be 2c squared plus 10c minus 3c minus 15. Okay, that's the first grouping. Let's do the second grouping here in red. So that the second grouping, we have three things multiplied together. And we haven't done a lot of examples like this, but what you have to remember in multiplication, if you had like regular old numbers multiplied like this, okay? If you had regular old numbers multiplied, you would just multiply the first two to get 10. And then you would multiply that by whatever's left over, and you just keep working yourself across, and so this becomes 30. We don't distribute over multiplication. We don't distribute. In multiplication, we just do this first two together, and then the product of that times the third one, and so this is 30. So we do the same thing if it's expressions. So you have to do this in two parts. So I'm going to do plus. I'm going to make this another set of brackets so I can keep track of everything. So I'm going to distribute the 3 into this first expression. I'm going to do that first. So this is going to be 3c minus 9. Okay, so that's going to be the first part there. And I'm going to bracket that around. Now I've got factors in one expression now. And now I multiply this by negative 3c plus 1. So I just rewrite the second part. You see, I've done this multiplication, check. Now I do this times this one. So good idea to show each step complete. So I'm just going to rewrite some of this here. And now I'm going to do this multiplication. So this is going to be, I'll do brackets again so I make sure that I keep everything separate for now. Negative 9c plus 3c plus 27c. Yep.
Wouldn't it be negative 9c squared?
Squared, thank you. Yep, negative 9c squared. That's exactly right. Plus 27c, good. And then the last one, minus 9. Okay, let me get rid of this now. Okay, so that's how we kind of manage that. Three things multiply the first two, and then that product multiply this third one. Okay, so now we can gather all like terms. The reason why I put these brackets here, guys, is because if this operation was a minus, we would have to subtract each term. We would have to, in effect, distribute the minus. So subtracting gets a little more complicated, but I always kind of try and put the brackets around there. And then if it's a plus, now you can just remove the brackets because you don't have to subtract anything. So now you can remove the brackets and, well, which I don't know if that really helps, but because it's plus, you can remove the brackets. So this becomes a plus negative 9c squared or just minus 9c squared. Okay. Well, let's just do this one at a time. So c squared, I have 2c squared, and I'm adding negative 9c squared. So that's 2 minus 9 is what? Negative 7c squared. Good. I'll stroke those out because I've taken care of those now. I have a bunch of c's, so let's see. 10 minus 3 is 7c, and then over here I have plus 3c, so that's 7 plus 3 is 10, plus 27c. 37c. So 10 minus 3 is 7, plus 3 is 10, plus 27 is 37c. Everybody got that? We good with that? Awesome. Now we have negative 15 plus a negative 9. So negative 15 minus 9 is minus 20 what? 4. Okay, and that would be our simplified answer right there. Okay, any questions there? Okay, so here's a very, very similar question for you, whoops, to try on your own. So go ahead and just jot that down as an example and see what you come up with. I'll show you the answer in a moment. All right, so once you've had a chance to give that a go, I believe that this should be your answer for that question there. Once all the like terms are gathered, you'll notice that the m squared terms cancel each other right out. So there's no m squared term there. All right. Any questions about that one? All right, and there's your assignment. You can be found on mrmathwell.com, obviously, right here. You have all the homework and videos that you'll find there on the website. So